Before I discuss the sequence of a muscle contraction, aka the sliding filament theory, let us first discuss the function of these structures, which is also important in the muscle contraction. So first, let's start with these structures. So this is what you call the T-tubule or the transverse tubule. The function of it is to convey action potential inside the muscle and delivers it towards the sarcoplasmic reticulum. On the other hand, the sarcoplasmic reticulum stores and releases calcium. Now let's discuss the filaments. First, we have what you call the thin filaments. We actually have three. We have the actin, the tropomyosin, and the troponins. So let's discuss first the actin. Actin, this one, the circle, is double-stranded F-actin protein molecules. On the other hand, tropomyosin, the red one, is a spiral over the actin that covers the binding sites. As you can see, may kinakoveran siyang binding sites. Then, hindi magpapauli ang mga troponins, the I, the troponin I, the troponin C, and the troponin T. Troponin I covers the binding site. Kumbaga, siya yung secondary cover ng actin. Kasi ang primary cover ng binding site is the tropomyosin. On the other hand, the second cover of the binding site ay si troponin I. Next, troponin C has a high affinity with calcium. I will discuss later kung ano yung importance niya. Next, troponin T forms a complex called troponin-tropomyosin complex, which is also important for the muscle contraction. So now let's discuss the relationship of these thin filaments. Just to let you know, kapag walang cover yung binding sites ng actin, yung mga yan, ang tendency niyan is kakapit sa kanya si myosin para magkaroon ng muscle contraction. But of course, we don't want na ang body natin ay laging nagko-contract, di ba? Kaya nandyan ngayon si tropomyosin at saka si troponins para i-cover yung binding sites. Didiscuss natin kung paano sila nawawala, paano na-uncover yung binding sites para makadikit si myosin. So, una muna, di ba naka-cover sina tropomyosin, pati si I, si C, at si T. Ngayon, kaya kasi dikit-dikit si I, si C, at si T ay dahil sa tinatawag na troponin-tropomyosin complex, which is the function of the troponin T. So, kaya sila ngayon nakadikit kay tropomyosin. So, ngayon, kaya magkaka-muscle contraction kasi may dadating na calcium. Ano ba ang importance ni calcium? So, the importance of calcium lies with troponin C. Kasi, di ba dadating si calcium? Di ba si C, sabi ko, ang function niya is high affinity with calcium. So, once na dumating si calcium, hahabulin ngayon siya ni troponin C. Pag hinabol siya ni troponin C, masisira na tong troponin-tropomyosin complex. Therefore, pag nasira tong troponin-tropomyosin complex, ma-expose ngayon yung actin binding site. So, pag na-expose si actin binding sites, syempre, ngayon, meron tayong tinatawag na myosin. Ito yon. So, itong si myosins, since wala na to, na-expose na siya, na-expose na yung binding site, ito ay kakabit dito. Pag kumabit siya, doon na magsa-start ang ating muscle contraction. Since we already discussed some parts and its function, let's move on to the real sequence of muscle contraction, aka the sliding filament theory. Now, in your book, actually, sunod-sunod talaga yan ng 1 to 10. Bale, meron talagang nakalagay na 1 is blah blah blah. But in here, I will just discuss the whole process. Then, tsaka nyo na lang siya pag sunod-sunod din or compare it with your book. Okay? So, just to let you know before we start, this is what you call the neuromuscular junction. So, muscle contraction actually starts once the action potential arrives at the presynaptic terminal. So once the action potential arrives at the presynaptic terminal, it will trigger the opening of the voltage-gated calcium channel. Once this voltage-gated calcium channel opens, calcium will go in, or influx of calcium will occur. This will trigger the release of the acetylcholine, or the ACH, which are neurotransmitters, into the synaptic cleft. Once the ACH is released, mag-a-attach ngayon siya sa tinatawag na ACH receptors. Once the ACH binds with the ACH receptors, production of new action potential will occur. The new action potential will then go to the transverse tubules or the T-tubules, which will convey the AP inside the muscle and deliver it towards the sarcoplasmic reticulum. Di ba ang function ng ating sarcoplasmic reticulum is the storage of calcium? So, once na dumating si action potential sa sarcoplasmic reticulum, it will trigger the release of the calcium na nasa loob ng sarcoplasmic reticulum. Once na lumabas si calcium, pupunta ngayon siya dito sa diniscuss natin kanina, which is the actin. So, di ba, lalabas dito si calcium, tapos makikita siya ni troponin C. Di ba, we said earlier that troponin C has a high affinity to calcium. Therefore, sasama siya doon. Once na sumama si troponin C doon sa calcium, masisira na tong troponin-tropomyosin complex and therefore mabubuksan or ma-uncover yung actin binding sites. Once na ma-uncover yung actin binding sites, didikit ngayon si myosin doon sa binding site na yon. Now, si myosin kasi may dalawa siyang head. Kapag relax yung muscle, yung ATP naka-attach dito. Relax muscle to. Relax. Pag relax, naka-attach si ATP dito sa head ng myosin na to. Ngayon, kapag hindi relax ang muscle or nagko-contract yung muscle, mawawala yung ATP. Magde-detach yung ATP. Kaya siya magkakaroon ng contraction. Okay? Now, let's repeat. Since na-uncover na tong binding sites, didikit na tong si actin attachment head doon sa binding sites. Once na nagdikit na siya sa actin binding site, power stroke would occur. Myosin tilts its head to pull the actin inward. So, ito, kumbaga ganyan, igaganon niya yung actin. Hihilahin niya. Tapos, habang nangyayari yun, si ATP na nakadikit dito sa head na to is nakadetach. Ngayon, once the ATP attaches back to this head, bibitaw na rin tong kabilang head dito sa actin, kaya magkakaroon ng muscle relaxation. Okay? So, ulitin-uli natin lahat yung step-by-step process ng muscle contraction para magets nyo uli. Ulitin natin. Okay? Si action potential, dadating siya sa presynaptic. Once action potential arrives in the presynaptic, it would trigger the opening of the voltage-gated calcium channels. Once this channel opens, si calcium ay papasok. Influx of calcium will occur. This will trigger the release of the acetylcholine in the synaptic cleft. Pag na-release si acetylcholine sa synaptic cleft, magbabind siya dito ngayon sa ACH receptors. Once na magbind siya kay ACH receptors, ay mag-generate siya ng bagong action potential na pupunta ngayon kay T-tubules. Once na napunta na siya kay T-tubule, i-convey niya na yung AP sa muscle pati papunta sa sarcoplasmic reticulum, which is the storage of calcium. That action potential will trigger the release of calcium from the sarcoplasmic reticulum na makikita ngayon ni troponin C. Once troponin C ay pumunta or sumama kay calcium, mawawala na yung troponin-tropomyosin complex and therefore will expose the actin binding site. Once the actin binding site is uncovered or is exposed, this myosin head, this attachment of myosin head will attach to the binding site and the ATP will detach. Okay? Pagkatapos nun, magkakaroon ng power stroke in which yung myosin hihilahin yung actin inwards. That would cause muscle contraction. Once the ATP attaches back to the head of the myosin, magde-detach na ngayon itong head na to from the actin. So, aalis na siya. Therefore, magkakaroon na ng muscle relaxation. And yun yung tinatawag na sliding filament theory.